When it says 20% of vehicles sold are compact cars. So is this a parameter or a statistic? Right. Well, notice that it says 20% of vehicles sold. So this would include all vehicles. So this would be a parameter. All right. In a sample of, and the key word here is sample. In a sample of students who passed statistics, 70% used statistics in their future careers. This would be a statistic, right? Because of the word sample. C says in a hospital recently surveyed, all their patients are found that 85% were satisfied with their level of care. Now, even though you see the word survey, and usually when you pass out a survey, you survey a sample, a certain amount of people. But this thing said a hospital recently surveyed all their patients. So all their patients would include the population of patients, right? So that would be considered a parameter. All right, D, Facebook recently tested all of their servers and found that 99% were performing as intended. Since Facebook tested all their servers, this is going to be a what? Okay, this should be unlocked. But I'll check them. I'll check them.
They have unlocked.
Oh, okay, okay. I'll check. I'll check.
And you got the NR passcode.
Okay, okay. All right. For number 2, it says in a study, the data you collect is gender, and is this data quantitative or qualitative? So remember that quantitative data has some type of numerical value. Qualitative data is categorical data. So gender would fit in the realm of categorical data, so that would be qualitative. Okay. All right, and then lastly we have to, well, nextly, excuse me, we got to match the variable with its level. There's some handouts on the back. With this level of measurement. So remember, there's 4 levels of measurement. We have interval, and in the interval level of measurement, there is no meaningful zero. For nominal, that's categorical data. Ratio data has a meaningful 0. And then ordinal data is rank data. Right. So as we're choosing level of measurements, we're just going to keep the definitions in mind. So A says,
can you give an example of interval one more time?
Interval would be like temperature.
Okay.
Where it could be 0 degrees, but that doesn't mean that there's no temperature. That just means that the temperature is cold. Okay. All right, so A says habits on always, sometimes, or never. So we talked about this. This is a Likert scale of measurement, and this is considered to be ordinal. All right, so A is ordinal, which is D. Gender, looking at the definitions, gender just going to be categorical, right? Male or female. So gender is nominal data. The temperature in Celsius, well, we just mentioned that for temperature, the 0 is not meaningful, right? So temperature in Celsius is interval. letter grades of A, B, C, D, or F. Ordinal, right? Because that's a rank order for grades. What about wages per hour? That would be ratio, right? Because a true zero means you get paid nothing an hour, all right? So that is ratio. And what about age in years? So like the zero means something. Well, if you're 0 years old, that means that you're not born, or age itself starts at, well, I guess you could be like a day old or 2 days old, but since 0 means something as far as age is concerned, that would also be ratio.
And why not ordinal?
Well, because ordinal is like a rank.
Okay.
So if you were like, if you had 4 people and you had to rank them according to their age or something to that effect, but for just simply someone's age, that would be ratio. All right, any question about number 3? All right, number 4, it says determine whether the value is discrete or continuous. So just remember that for discrete data, it's countable. And for continuous data, it's not countable or infinite. Right. So the outside temperature, is that discrete or continuous?
Continuous.
Continuous, right? So that would be continuous. All right, now problem number 5. And this kind of goes back to the very first lecture, I believe, when we had to take the data set, from the data set, construct a frequency distribution, right? So we have to construct a frequency distribution. We have to list out the class ranges for each class and the frequency, right? So here are the steps. The first thing we must do is we put the data into the calculator and put in ascending order.
Mr. Cummings, are you going to upload this?
Yes, yes.
Okay.
All right, so I'm going to pull up the calculator. All right, so in order to put the data into the calculator, I'm going to hit Stat, and we're going to choose this first option, which is Edit. The second thing we do is return to the home screen. All right, so once I put the data into the calculator, I'm just going to return to the home screen. I'm going to hit second in mode. All right, now in order to sort the data, I'm going to hit Stat, and we're going to put it in ascending order. So I'm going to hit Sort A, right, which is short for ascending order. So I'm going to hit Enter. Okay, so we have to input the list in which we want to sort. So we just put that list in as list 1. So in order to recall list 1, I'm going to hit second and number 1, right, which recalls list 1.
I want to see how you close the parentheses because I got the devil doing that.
And then to close the parenthesis, I just hit this in parenthesis. Okay. And that closes off the function. So that was second and right. So now if we hit enter, okay, it doesn't appear that it done anything. It just says done, but it's actually sorted the list. All right. So now we're going to view the list. And now we can go ahead and get started constructing the frequency distribution. So in order to view the list, I'm just going to hit stat. And I'm going to choose edit. So notice that your list is now in order from smallest to largest. So that's the first thing, is organizing the data. Put it in a calculator, put it in a list, and sorted it from smallest to largest. All right, so now once we have the sorted list in the calculator, the next thing we're going to do is find the class width. Right, so there's a formula for the class width. The class width is equal to the maximum value in the list minus the smallest value in the list divided by the number of classes. So that's an actual formula. So I'm going to use a calculator. I'm going to pull out the largest number. So I'm going to scroll to the very end. It looks like it is 69 minus the smallest number on the list is 15. And we're going to divide by the number of classes, which is 6, right?
Oh, okay. Yeah.
Right. So they must give you the number of classes.
Okay.
All right. So 69 minus 15. Well, let me go back to the home screen. So this is where you got to be careful. 69 minus 15. That's going to give you 54, right? 54 divided by 6 should be 9. $54 divided by 6 is 9. But what must we always do? Round up to the nearest integer. So if we round up 1, we're going to round this 9 up to 10. Round up to the next integer. So our class width is equal to 10. So let me let that look like a 10. Any questions about that? We did one in the, I think we did one before. You got like a decimal or something. Even with whole numbers, you still have to round up to the next integer. All right, because if the class width is off, then everything else from this point going forward is going to be off. All right, so we found the class width, which is 10. So the only thing we want here is the classes and the frequency. Okay. So now here's how we're going to construct the classes. If we look back at our list of sorted numbers, so I'm going to just clear out my home screen. I'm going to hit stat, and I'm going to hit enter because we're going to choose edit. We're going to choose the smallest number in the list, which is 15. I'm going to use my class width, which we found is 10, and I'm going to find the next lower class limit. So if I add my class width, my next class should start at which number? 25, right? So remember, the definition of the class width says if you subtract consecutive classes, that will give you a class width. So this is 10, 15, 15, 25, 35, 45, 55, 65, so now if my second lower class limit is 25, that means that the upper class, the previous upper class limit should be what? 24, right? And then I could just keep adding 10. So that's 24, 34, 44, 54, 64, and 74. And all of our numbers would fit, right, in the ranges, because our largest number, I believe, it's 69. Right, so everything would fit nicely in the classes. And now we're going to pull out the frequencies. All right, so I'm going to go to the top of my list, and I want to count the number of numbers between 15 and 24. So like it's 1, 2, 3. So the frequency is 3 for the first class. From 25 to 34, it looks like 1, 2, 3, 4, right? 4 numbers. 35 to 44, 1, 2, 3. 45 to 54, 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. That looks like 5. 55 to 64. So that's 1, 2, 3. Looks like 3. And then 65 to 74 looks like 2. All right, so this is the extent of this problem. Just list out the classes along with the frequency. All right, any questions about this problem? Probably seen that a couple times in the homework. All right, now the next problem, same sort of thing. You're given a frequency distribution. So now the way that this thing printed out is not going to look like this on the test. It's just the print version has its own way of like formatting things. All right, it has its own way of like formatting things. So here it says a randomly selected group of individuals were asked how many marbles they believe were contained in a sealed jar. The following frequency distribution summarizes the results. Complete the table by determining the midpoints, relative frequencies, and cumulative frequencies. So what you actually see here is for this very first line, that would be the marbles. So here, from 200 to 208 marbles, there was one person that guessed that was how many marbles in the jar. 209 to 217, 4 people guessed within that range. 8 people within the next range. 6 people within 227 to 235. And then 7 people estimated that there were between 236 and 244 marbles in the jar. So I'm going to halfway use this as my frequency distribution. So this column is for my classes. For this column, I'm going to put in the frequency which they give us, just situate out everything a little bit better. So for my first class, that frequency is 1. The second class is 4. The third class has a frequency of 8. The fourth class has a frequency of 6. And the last class has a frequency of 7. In the next column, we want to find the midpoint. So remember the formula for the midpoint, it was the upper class limit plus the lower class limit divided by 2. So for this first class's midpoint, all right, I'm just going to add the lower class limit plus the upper class limit divided by 2. So the midpoint for the first class is 204. And from this point, I could add and divide all the way down, or I could do what? I could find the class width, and I could just repeatedly add that class width. So what would be the class width for this problem? Well, in order to find the class width, I would subtract consecutive lower class limits. So for my class width, here I have a lower class limit of 209. Here I have a lower class limit of 200. So remember, consecutive means that they have to be back to back. 209 minus 200 is 9. So that's my class width. So that means I can repeatedly add 9 to my midpoint. So 204 plus 9, that should give us 213. If I add 9 again, that's 222. Right, just repeatedly add 9. 222, 231, and then 240. So those are the midpoints. We're going to add another column for the relative frequency. So remember, the relative frequency is found by dividing the class frequency by the total frequency. So what is the total frequency? Well, if we add up all of these numbers, right? 1 plus 4 plus 8 plus 6 plus 7, we get 26. Right, there were 26 total counts. So in order to find the relative frequency for the first class, we can divide the frequency for that class by the total frequency. So 1 divided by 26 is 0.038. Right, so we want to answer as decimals rounded to 3 decimal places. The relative frequency for the second class is the frequency for that class, which is 4, divided by the total frequency, which is 0.154, right? Because we're rounding to 3 places after the decimal. The next relative frequency is 8 divided by 26, which is 0.308. The next relative frequency is 6 divided by 26, which is 0.231. And for the last class, the relative frequency is 7 divided by 26, which is 0.269. So not too terribly difficult to construct just knowing these formulas. And then the last is the cumulative frequency. So remember, the cumulative frequency is the frequency of that class in all classes prior. So we take a look at the first class. It has a frequency of 1. There are no prior classes, so the cumulative frequency for the first class is 1. The cumulative frequency for the second class is the frequency for that class, which is 4, plus the prior class frequency, which is 1. So that gives a cumulative frequency of 5. For the next class, the cumulative frequency is the frequency for that class, which is 8, plus 4 plus 1, which is 13. Then I believe we have 19, and then last we got 26. So remember that these two numbers must match. All right, any questions about number 6? All right, number 7. It says identify the histogram for the frequency distribution below. Now, I don't believe I actually did talk about a histogram. I talked about a stem and leaf plot and a bell-shaped curve, but this is the histogram. You'll just notice on the histogram, we have a horizontal axis, and on that horizontal axis, it represents the classes. So notice like on this first interval from 2 to 7, they're simply listing out those lower class limits from 2 to 7. Then we have from 7 to 12, from 12 to 17, 17 to 22, and then they went from 22 to 27. Right, so everything's within the range. So within this first class interval, from 2 to 6, there should be a total of 1 count. So on the horizontal axis, we have the classes or the lower class limits. On the vertical axis, we have the counts or the frequency. So the first thing I'm going to do is look for a frequency of 1 for the first class from 2 to 6. Well, if I look at this first example, this could fit, right? Because from the range from 2 to 6, Notice my scale is going by twos for whatever reason. So this is a candidate, and I believe this is a candidate, right? But the other ones, that first class exceeds 1. So I can throw the last two, or at least the last two that we're looking at here, because it's orientated a little bit different, right? For the second class, from 7 to 11, I should have a count of 2. If I look at this first diagram, it has no count, so that eliminates this histogram. So by the process of elimination, our choice is this histogram, right? Between 7 and 11, we have 2 counts. Between 12 and 16, there are 3 counts. Between 17 and 21, there are 6 counts. And between 22 and 26, there are 3 counts. All right. Okay, now we'll take a look at number 8. And for number 8, there's some handouts over here on the, right over there. Okay, for problem number 8, this is a stem and leaf plot. Okay, so we talked about a stem and a leaf plot, and I mentioned this little key or this legend, but we'll go in a little bit more detail as far as this key is concerned that they give you. So it says the stem and leaf plot above shows house sale prices over the last week in Tacoma. So what you actually are seeing here are the prices of houses sold in Tacoma. What was the most expensive house sold? Give your answer in dollars. Right. So first thing is, let's focus in on this key. So notice the key says that the very first number, this stem, it represents 1 in 120,000. The one that you see is in the 100,000s place. So the first number in this key represents the 100,000s place. The next number in the key, so if we look at 120,000, the 2, it represents the number in the 10,000s place. So like if you had to read this, like if I had to read this very first number, since there is no number in the 100,000s place, we have this 6 in the 10,000s place. This number would represent 60,000. If we take a look at, let's say, this number, it has a stem of 2, so that means that the 2 is in the 200,000s place. The leaf is 9, and the 9 is in the 10,000s place. So this number is actually represented as 290,000. So now if they're putting these things in order, the most expensive house would lie here, right? So what is the sale price for that house? Right, 3 is in the 100,000s place, 3 is in the 10,000s place. So the most expensive house sold was $330,000. And that actually represents that very last value. So the most expensive household was $330,000. All right, any questions about that one? All right, the next one we have a dot plot. And for this dot plot, we're asked a couple questions. So first, on how you interpret this dot plot. On the x-axis, we have a number line. It goes from 23 through 37. So this thing says the dot plot outlines the result of scores on a standardized exam. So on the bottom axis, you see the standardized scores. On the vertical axis, these are the counts or the number of students at a particular score. Okay. So what this means is there were 3 people that had a score of 25. There were 2 people that had a score of 26. 1 person had a score of 27. No people had a score of 28, so on and so forth. It says how many data items exist in the data set. Right? Well, I'm just going to count the number of dots because each dot represents a test score. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There are 19 data items in this set. What is the mode of the data set? So remember, the mode is the number that appears the most. So it looks like there are 3 numbers that appear the same amount of times. 25 would be considered a mode value. It appears 3 times. 29 is a mode value. And also 35. So this particular data set has 3 modes. All right, the last one says what percentage of values are greater than 30? Answer with a whole number. So now I want to find out of these 19 data scores, right? So remember, for a fraction, the denominator is the base or the total. The numerator is the part. So we got a total of 19 data set scores. How many of those scores are greater than 30? Right? So when I start counting, I'm not going to use the scores at 30 because we want the percentage of scores greater than 30. So I want to count the number of scores greater than 30. So it looks like 1, 2, 3, 4, 5, 6, 7, 8. The portion of scores greater than 30 are 8. So we're going to divide 8 by 19. We get 0.421. I want to convert this to a percent. So in order to convert a decimal to a percent, I move the decimal 2 places to the right. So this is like 42.1%. Since we only want to answer as a whole number or a whole percent, I'm going to round this to 42, right? Because I'll round to the nearest whole number. So this is 42%. So there's 42% of numbers in the data set greater than 30. So this is a dot plot. All right, number 10. And I believe this should look familiar from the last class when we talked about that weighted average thing. This one just says in one particular month, a person carries a balance of $3,460 for 8 days, $4,290 for 9 days, $2,670 for 14 days. What is their average daily balance? Right. So here we're going to list out the balance in one column. In the next column, we're going to put the number of days. Okay. In the next column, we're going to multiply the account balance by the number of days. And then we're going to calculate the average daily balance. All right, so our first balance was $3,460, and that was in the account for 8 days. The next balance after a purchase was made was $44,290 for 9 days. And then we had $2,670 for 14 days. All right. Okay, so now that we have everything listed out, in this third column, I'm going to multiply the balances times the number of days. So now I'm going to add all of these up. 27,680 plus 38,610 plus 37,380. That's 103,670. And you also have to sum up your number of days. 8 plus 9 plus 14 is 31. And then lastly, we divide. So the average daily balance is 103,670 divided by 31. $3,344.19. Always round money to the nearest hundreds.
I have a question. I didn't learn from the homework. Is it okay that we always put them in like as a list and do like the stats?
You can.
Okay.
You can. All right. So that is number 10. All right. Number 11, we're given a data set and we're actually finding the mean, the median, the standard deviation, and the range. So I believe the easiest thing to do for this problem is we're going to put the data into the list and we're going to use the one variable statistic. Okay. So put the data into a list, and then 2, we're going to use the one variable statistics. All right. So in order to put the data into a list, all right, that's just stat and hit enter. To quickly clear a list, I'm going to go to the very top. I'm going to hit clear and enter. That wipes out the list. And I'm going to just put in the numbers. Okay, make sure you hit enter after every data value. All All right, so you put the data into the list, and once you do that, you must return to the home screen. And then we can calculate the one variable statistics. All right. So I'm going back to my home screen. I'm just going to clear that off. Now I'm going to hit Stat. Scroll over to calculate. The first option is the one variable statistics. So I want to hit enter once, hit enter again. Now by default, it defaults to list 1. So you can use other lists, but if you use the one variable statistics, you have to tell it what list if you're using something other than list 1. So now we want to find the mean. So remember that the mathematical symbol for the mean is this X bar. So the mean is 2.96. We want to find the median. So if I scroll down, the second quadrant, or the second quartile, Q2 is the median, but they have it spelled out as the median, that's 3.15. The standard deviation, I can scroll up because you can go up and down in this output. So remember, I have 2 standard deviations. One is S of X and one is sigma. Which one would I use? Since this is a sample of numbers, I'm going to use that sample standard deviation. So remember, this one with the little circle, that's population. The S of X is the sample. So if we round that to, okay, I'm supposed to be rounding to 3 decimal places. That would be 0.941.
On the median, it was 3.15.
Yeah, the median is 3.15, and then mean is 2.96. Now, there is no output for the range, but the formula for the range is the maximum value minus the minimum. And they do give us the 5-number summary. So the maximum value is what? 4.3. The minimum value is 1.1. If we subtract the 2, we should get what? 3.2, right? So that's our range. Okay. So I simply took that max value of 4.1 minus the smallest number in the list, 1.1, and that's where the 3.2 comes in. All right, so that is number 11. All right, problem number 12. And I don't think we actually did one like this in the lecture. This says every year the students at a high school are given a musical aptitude test that rates them from 0, which is no musical aptitude, to 5, which is high musical aptitude. So here again, this is that Likert or ordinal scale. This year's results are given in this frequency distribution. So for the first row, we have the aptitude score. For the second row, we have the frequency. We're asked to calculate the sample standard deviation. We only want one statistic. So what we're going to do is for the aptitude score, we're going to put that in as list 1. The frequency is going to go in as list 2. And then we're simply going to do the one variable statistic. We're going to use that function. Okay. So the first thing was going to enter in the aptitude as list 1. We're going to enter the frequency as list 2. So I'm going to do that now. So I'm going to just clear out my home screen. I want to go into the list. So I'm going to hit Stat, and I'm going to hit Enter. I'm going to go to the top of list 1. I'm going to hit Clear and Enter. Okay, and my list 2 is free, right? So I don't have to clear anything out. For list 1, I'm going to put in the aptitude scores. So I don't have to find any midpoints because they just give us a single numerical value as the X value. All right. So we put in the aptitude as list 1. We're going to put in the frequency as list 2. We're going to return to the home screen, second in mode. Now we're going to calculate the standard deviation. So I want to go into Stat. I want to scroll over to Calculate. We want to use one variable statistics. We're working with 2 lists, so keep that in mind. So for my calculator, I'm going to put in list 1, comma, list 2. If you have a TI-84, I believe it's X list, you put in L1. And then what is it? Y list and frequency? Because I'm not actually looking at a calculator.
On the video on homework, it looks like it kind of populates the frequency. Mine's an 83, so you have to do the comma, but on the one from the homework, it looks like it.
Yeah. So I think it's what, X list, and is it Y list? Once you do that, I think it's Y, it's frequency list, I'm sorry.
It actually just gives you where it says frequency list on the
And then it's calculate. Okay. So once you hit enter, your output should look like this. Right, and we asked for the sample standard deviation, so we're going to use this S of X value rounded to 2 decimal places, so it looks like it's 1.58. So that should be 1.58. So remember, you want to use the S of X for sample, the sigma sub X for population standard deviation. All right, so that was number 12. For problem number 13, did I not put the directions on? I didn't even put the question. You got to find the population mean, so you may want to write this in. It's on there?
Yes.
Oh, it's not on this, though. Okay. The population mean and the population standard deviation?
Two decimal places.
You said the population standard deviation, that's the little circle looking one?
Right, right. Okay, now we completed one like this in class. The difference between number 13 and number 12 is that for number 12, we didn't have any class ranges. We just simply had 0 through 5. For number 13, we have class ranges. So for this particular problem, we want to change our data to the midpoint. We use the midpoint as L1. We're still going to use the frequency as L2. So I'm going to just clear out the home screen. I want to find the midpoint for the first class. So remember that formula is to add the lower class limit plus the upper class limit and divide by 2. So the midpoint for the first class is 32.5. From this point, I could continue to add and divide, or I could add my class width. And the class width for this particular problem is what? 6, right? Because 36 minus 30 is 6. So I can repeatedly add 6. Right. So my next class is 38.5. If I add 6 more, 46.5. If I add 6 more, 52.5. If I add 6 more, 58.5. And if I add 6 more, well, I wouldn't add 6 more, right? Because if I add 6 more, I'm going outside of my range of numbers, right? 1, 2, 3, 4, 5. Well, I have 6 classes, so I have to add 1 more. 1, 2, 3, 4, 5. So I do add 1 more. So 6 more would be 64.5. Okay. So now the frequencies remain the same. So now we have the midpoint and the frequency. We're going to put in the midpoint as L1. So I'm going to just clear out my list 1 and list 2. And I'm going to double check 32, 38, 46, 52, 58, 64, 14, 18. All right, so it looks like I have everything in. So once you put in the data, return to the home screen. I can calculate the population mean and the population standard deviation. We're going to go into stat, scroll over to calculate. Okay, 1 variable statistics. And just as in the previous problem, you have to input the X list and the frequency list. X list is list 1, frequency list is list 2. I'm getting something different than the answer key. Let me look at my values. 32, 38. $44, $50, $56. That was throwing me off. 62.5. So I had something not right going on here. All right. So make sure you got the right midpoint. So let me just clean this up. 32.5. 44.5. 50. I got ahead of myself. 56.5 and then 62.5. So let me just, okay, 38, 44, 50, 56. Okay, so this looks right. 14, 18, 14, 8, 5, 3. So I'm going to go back to the home screen. I'm going to go back into the one variable statistics, and this looks a lot better. So the population mean, that's X bar, that's 42.66. We're around 2 decimal places. The population standard deviation, we're going to use that sigma sub x, and that is 8.46. All right, so the only difference here is we had to find the midpoint. All right, any questions about 13? All right, number 14 uses the empirical rule. All right, this should look somewhat familiar from the last class. All right, so this says that the Acme company manufactures widgets. The distribution of widget weights is bell-shaped. The widget weights have a mean of 38 ounces and a standard deviation. When I glued these things together, I did a digital cut and paste, and the standard deviation is 3 ounces, right? Okay. So it says 95 of the widget weights lie between what two numbers? What percentage of widget weights lie between 38 and 47? What percentage of weights lie between 35 and 41? So I'm just going to map this out. The mean is 38 and the standard deviation is 3. So that means in the middle we have 38. That's our mean. If I add 1 standard deviation, 38 plus 3 is 41. If I add 3 more, 44. If I add 3 more, 47. And now I'm going to go in reverse. So notice I'm following these formulas. So X bar is 38 and S, which is the standard deviation, is 3. So here I have X bar minus S. So 38 minus 3, 35. If I subtract 3 more, 32. And if I subtract 3 more, 29. Right? So now let's answer the question. So we have the raw data scores on the bottom. We also have the associated area. So number A says 95% of the widgets weight lie between what two numbers? So if I look at my 95, they should fall between 32 and 44, right? So that's 32 and 44. B says, what percentage of widget weights lie between 38 and 47? This is where you got to be careful. Because between 38 and 47, what's my area? Would I add all these things up? Now, this is why I wouldn't necessarily add all of these up. If I were to add, let's say, 34% plus 13.5% plus 2.4%, right? So I got to get 49.9. If you look on the answer key, that's not the answer. This is how you answer this question. Between 38 and 47, that's going out 3 standard deviations above the mean, right? So if you take a look from here, from 29 to 47, there should be how much of the data? 99.7, right? From 38 to 47 is half. So if I take 99.7 and if I divide that by 2, that's where the 49.85 comes in. Is everybody okay with that? Because if you put in 50 or 49.9, it's going to mark it incorrect. Because, so just to review that, from 29 to 47, according to the empirical rule, that's 99.7% of the data. So if I'm going from 38 to 47, I'm taking half of that 99.7, which is 49.85. All right, so we did not talk about that in class. We just simply kind of added the stuff down there, but there's a little bit more going on, especially if you're going from one extreme to the other. All right, so that's 49.85%. Now the last one says, what percentage of weights lie between 35 and 41? And that should be 68%. Because there's 14% here, 34% here and 34% here, which is a total of 68%. Any questions about 14? All right, so you may want to have this empirical rule handy. All right, number 15. It says pulse rates in beats per minute, that's BPM. They were collected from a sample of females who were non-smokers but do drink alcohol. The pulse rates before they exercise had a mean of 75.74 and a standard deviation of 10.65. The pulse rate after they ran in place for a minute had a mean of 125.25 and a standard deviation of 24.14. The pulse rates before they exercise, were they more consistent or less consistent? To answer this problem, I'm actually going to sketch out 2 bell-shaped curves. And I'm going to put one over the top of the other. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 130, 140, 150. I got to go out to like 200. And this one is supposed to be lined up the exact same way. Okay. All right. So now what I did is actually put out a number line from 10 to 200. Up here, I'm going to map out the bell curve. This is before the exercise, and this was after the exercise. All right. So if I look at before the exercise, it says that they had a mean of 75.74. 75.74, and they had a standard deviation of 10.65, right? So I'm going to take 75.74 minus 3 times the standard deviation, which is 10.65. I get 43.79, right? So what I just put in, this is the mean minus 3 standard deviations below the mean. So 43.79 is about right here somewhere. 75.74 plus 3 times the standard deviation is 107.69, which is about here. So that's what that curve looks like. Is everybody okay with what I did? I just took my mean, and this is just a rough sketch. I took my mean, which is 75.74, and as you can see, that's exactly 75.74. All right. That's somewhere near my mean, and notice this is what that bell-shaped curve looks like before they exercise. After they exercise, they had a mean of 125.5 minus 3 times the standard deviation, and that standard deviation is 24.14. So for my bottom, my 3 standard deviations below the mean was about 53, which is here somewhere. 125.5 plus 3 times the standard deviation gives me 197.92, which is like right here. And if I draw the curve, it looks something like that. So now, based on these two curves, notice that before they exercise, that curve is not as stretched out as much as after they exercise. So now here's the question. It says the pulse rate before they exercise, so this is that bell-shaped curve, were they more consistent, which means were the scores tight about the mean? So like this is my mean, and then notice that my scores, they don't really stray too far from the mean. But if I look at down here, this thing is like way over the place, right? Because you got the mean here, and then you got 3 standard deviations way down here. This is more spread out or less consistent. So that means that the pulse rates before they exercise are more consistent. Is everybody okay with that? It means that those pulse rates were closer to the mean before they exercised and after they exercised. All right, so that's number 15. Number 16, we're asked to pick out the correct box plot. So in order to pick out the right box plot, we're going to take these numbers, put them into the list. We're going to use the one variable statistic to pull out the 5-number summary. Because remember, the 5-number summary is just this box plot's physical representation. I was going to try to do these all. So I'm going to have to do another video for the last two. Let's see. So we're going to put these into the calculator as list 1. Right, so stat, we're going to edit the very first list. I'm going to put in 24, 26, 36, 36, 32, 29, 26, 24, 21, 17. So it looks like I have them all in for list 1. I'm going to return to the home screen. I'm going to go into calculate, scroll over to, well, I'm going to go into stat, excuse me. I'm going to scroll over to calculate. We want the one variable statistics. Right. If we scroll down, we get the 5-number summary. So for each one of these numbers, there should be a vertical tick on the box plot. So the first tick on the box plot should be at 17, and it looks like they're all at 17. The maximum is 36, so it looks like they're all at 36. Q1 is 22.5. So we can cross out this one, right? Because that's like that. This looks like it could be 22.5. This one could be 22.5. And this one, right? So let's go to the median, 27.5. Well, it looks like this one's out, right? That looks like it's at about 27.5. This is at about 27.5. That one is out. Third quartile is at 34. So it looks by the process of elimination, B has to be the correct box plot. This says a normal distribution has a mean of 76 and a standard deviation of 4. Find a z-score for a data value of 70. So remember, there's a formula. Z is equal to x minus the mean divided by the standard deviation. X is our value, our data value, that equals to 70. The mean is 76. The standard deviation is 4. So Z is going to equal to 70 minus 76 over 4. Which is negative 6 over 4, which is negative 1.5. And then for the very last problem, it's that regression type problem. We want to put this in as list 1. We put this in as list 2. We calculate the regression, and then we predict the value. So like really quick for this one, I'm going to put in, I cleared this calculator out. I'm going to put those in. So you got to clear out list 1, clear out list 2. So that's list 1. Okay, that's list 2. So remember, list 1, that's the X variable. List 2, that is the Y variable. All right, so I'll put the data into list 1 and list 2. I'm going back to my home screen. I'm going to clear that out. I'm going to stat over to calculate linear regression. This is the formula. Y is equal to 1.04 x minus 4.25. That is our equation. But what only thing we're asked for is to predict the value of the second quiz score to the nearest integer if a student had a score of 30 on the first test. So notice that X, so that's first quiz, which is this first test. 30 is an X value. We can take X as 30, subs it into our equation for Y, solve it, and Y would give us the prediction for the second quiz. All right. So we're going to put this in as Y is equal to 1.04 times 30 minus 4.25. 1.04 times 30 minus 4.25. And it says round to the nearest integer, so that would be 27. So remember that the integers are the positive and negative whole numbers.